Good morning. Welcome to unit number 2 of the course Basic Electrical Engineering. Unit number 2 is about network theorems. The first network theorem which we will be discussing is the superposition theorem. So far we have completed unit number 1. We have seen mesh analysis, we have seen nodal analysis, and in particular in the last lecture we have seen the nodal analysis and problems on nodal analysis. This mesh and nodal analysis, they help us in analyzing an electrical circuits. So we can determine the response in any of the elements of a given circuit using mesh analysis and also nodal analysis. And also we have seen how to simplify the circuit using resistances in series and parallel, and also we have seen voltage division and current division rule also. And we will try to employ all these techniques which we have discussed in unit number 1 for unit number 2. So in today's class I will start with the superposition theorem. I hope that today we will complete the introduction part, and by the end of this lecture you will be able to describe the steps of superposition theorem when it is applied to electrical circuits. So let's start with the statement of superposition theorem, and then I'll give the explanation, and then we will move on to an example problem on superposition theorem. So before we move on to introduction, you are supposed to remember a few things. The superposition theorem is a technique which is generally employed for analyzing any complex circuits, and it is applicable to linear circuits only. You know, linear circuits are those circuits which consist of only linear elements. And what do you mean by linear elements? Which have linear relationship between V and I, or I can directly say which do obey Ohm's law. Okay, so it means that superposition theorem is applicable to linear circuits, which means that the circuits which are present in the elements in the circuit must be obeying Ohm's law. Okay, and the biggest advantage of superposition theorem is that it helps you to analyze the behavior of individual components of the circuits. So you will be considering individual sources and you will be identifying the response, and like that you can observe the individual contribution of each of the sources. It may be difficult for you to understand, but first of all let me write to you. I'll take a simple circuit. Now let us suppose there are some 3 sources in the network and there are 2 resistors in the network. This is R1 and this is R2. I want to determine what is the current which is flowing in R2. So what I will do is nothing but this is I will take I1. Only one source is acting, 2 amperes. The other 2 sources are removed, and during this time the current is I1. Let us suppose this is I2. And this is I3. So this is a pictorial representation of the statement. So I decided to implement this one first of all for you. See, this is the current which I am supposed to determine when there are so many sources in the network. It might be possible for you to determine the current using nodal or mesh analysis, but if there is a very complex network and if you want to determine the individual contribution, then it is a little bit tough task. So in that case, what I will do is nothing but I'll take this current as a combination of three different currents, where these three different currents are the responses in the same elements when individual sources are acting. See, I1 is a response in the same element R2, but only when one single source is acting. I2 when this source is acting. I3 when this source is acting. Then what happened to the remaining sources? You can observe that here I have short circuited them, here I have shorted it open, here also shorted it open. If you see the similarity, you can see that the voltage sources, whatever the present, when they are to be replaced, they are short circuited. Whereas current source, in this case, I want to use only this source. I want to remove these two. So voltage source is short circuited, current is open circuited. Here also, if you see, the voltage source is short circuited, current is open circuited, which means that you can observe that voltage sources are short circuited, whereas current sources are open circuited. So what you can say, in a lead, the response in any element is equal to the algebraic sum of the responses when the sources are acting individually. See, I1 is the response when it is this source is acting individually. This source is acting individually. I3, this source is acting individually. So the response in any element is equal to the algebraic sum of the responses when the sources are acting individually, while the other sources are replaced by their internal impedances. Now the question arises, what do you mean by internal impedances? See, for a voltage source, the internal ideal case, internal impedance is 0. That's why it will be short circuited. If you want to remove it, you replace it with short circuits. A current source, ideally, its internal impedance is infinity. So if you want to remove it, you should open circuit it. So this is the ideal case. So that's why to remove this voltage source, what I have done, I have shorted it. Here also, I have shorted it. Whereas here, if I want to remove current source, I should open it. So now you frame the statement. The current, the response in any element. If you want to take voltage also, you can take the same. These are called as responses, right? So the response in any element is equal to the algebraic sum of the responses when individual sources are acting alone, while other sources are replaced by their internal impedances. Now, when is this applicable? Your network must be a linear network. And there are more sources. So I'll take 2 plus sources. If it is one source, then what is the need of superposition theorem? You don't need it, right? So that's why, see now the statement. In any linear bilateral network, having more than 2 number of sources, the response in any element is equal to the algebraic sum of all responses caused by individual sources acting alone, while other sources are replaced by their internal impedances. This is the statement. I hope you have now understood. Any linear bilateral network having more than 2 number of sources, these are the conditions. Any linear bilateral network and having more than 2 number of sources. Okay. Now, what I want, the response in any element is equal to algebraic sum of the responses caused by individual sources, while other sources are replaced by their internal impedances. Understood now? So, to apply the superposition theorem, you should consider independent source one at a time, while treating the others as though they are not present. So, what you should do? See, we will consider only one independent source acting at a time. So, we need to remove other sources. If you want to remove voltage sources, ideally they must be short circuited. If you want to remove current sources, ideally they must be open circuited. Okay. In practical case, you should consider their internal resistance or impedances. That will be given in your problem, in your higher levels. But at your BW level, you consider only ideal sources. So if you want to remove voltage source, it must be shorted. If you want to remove current source, it must be open circuited. Okay. And try to remember the point. It is applicable only to linear circuits, which means that it is applicable only to circuits which follow Ohm's law. Okay. So what is the procedure now? The first step, see, you first identify what is the number of sources in the circuits and you number them 1, 2, 3, 4, 5. In earlier case, what I have done, I is equal to I1 plus I2 plus I3. So what is the first step? I have identified how many sources are there. 3 sources are there. And I have numbered them 1, 2 and 3. So what next I am supposed to do? You turn off or replace all but one independent source. So I have drawn separate circuits, right? Which each individual source working. So replace other sources, let only one independent source is working, and you determine response. So 2 and 3 steps, what I will do? I will determine I1. Next, repeat step 2 and 3 for each independent source. So the same thing will be repeated again and again. I will determine I2 and I will determine I3 if more number of sources are there, I4, I5, I6 like that. So the situation will be repeated. And finally, what I am supposed to do? I am supposed to algebraically add all these things. Understood? So the first step, identify the number of sources. Next, draw the circuit with first source only acting. Determine the response. And repeat the same steps again and again. Now, second source is only acting, response. Third source is only acting, response. Fourth source is only acting, response. And finally, you add all these things, you will get a solution. Understood? So this is the way how we apply superposition theorem. Now we will solve a problem in the next video, and then we will practice some more problems in the next consequent video lectures. Okay.